All right. So angles formed by transversals. So probably one of the first things we need to talk about is, well, what is a transversal? So I think that's probably where our definitions start. A transversal is a line that intersects other lines. A line that intersects two or more coplanar lines at different points. We don't want them all to intersect at the same point, like in an asterisk kind of arrangement. We want it more like a capital H idea. We have two separate lines, and then the transversal intersects both of them. Now in that arrangement that I have on the screen there, how many angles are formed? There are 8. Right. Now those angles will have certain names, and that's what we're going to talk about, how you can pair them up and what that pairing is called. Now there would be vertical angles and linear pairs of angles in this diagram. Remember, vertical angles have to be just hooked together. So if you're talking about vertical angles or linear pairs, you're just using one of those intersection points, you're not using both of them. So we are going to pair up things using both intersections. Okay, looks like we're done with that part. Okay, corresponding angles is what the pair is when it's two angles that occupy matching positions. Now, not matching as far as flipping it over, not that kind, but matching as in, if I put a 1 here, that is above the line and to the left. So here, if I go above the line and to the left, that would be a corresponding angle. So matching, that's what I mean, like in the same position related to the lines. Probably be good to draw the picture and put some numbers on there. So 1 and 2 would be corresponding. There's actually 4 sets of corresponding angles. So that would be one pair. Another pair would be the upper, I guess I better set that down, upper right. That would be a second pair. It's just hard to put these all on one picture because you don't know what things pair up when I do that. Okay, if I go lower right, those are corresponding. And if I go lower left, those are corresponding. So it's the position in relation to that intersection. Which corner of the intersection is it? And then have a matching one. Second type, alternate interior angles. Alternate interior angles. Two angles that lie between the two lines, but on opposite sides of the transversal. The transversal is the one that intersects the other two. So we want to go on opposite sides of the transversal. So the way my picture is, we'll have one on the left side of the transversal, one on the right side. And they have to be between the two lines. Okay, so I'm going to kind of scribble between the two lines, we mean this part. So the angles for alternate interior are between there. So if I put a 1 over here, then the 2 would go in that spot. I'll get rid of the scribble so that you can see it better. So here's an example for your notes. Angle 1, angle 2. Alternate interior. Now I usually describe these as, do you see the Z? And what I'm talking about is if I would trace the sides of angle 1 and the sides of angle 2, notice how together that makes a Z. That's your alternate interior angles. So you might put that it makes a Z. The Z sometimes looks weird, because if I would do the other pair, angle 1, angle 2, notice how they're still between the pair of lines and on different sides of the transversal, one up here, one down there. The Z, there's angle 1, there's angle 2. It's still a Z, but it's kind of a stretched out Z. Like the first one was actually backwards. This one's backwards and stretched out, but it still makes some sort of a Z. Alternate interior. Then there's alternate exterior. So instead of being between the two lines, these are going to be outside of the two lines. Like one above, one below, the way that I've got it pictured. Wherever your pair of lines is. Above it and below it. As far as numbering those, I have to stay outside of the pair of lines. So outside of the pair of lines. So if I put a 1 up here, then on the bottom intersection, I want to go on the other side of the transversal and outside of the pair. So that would be a alternate exterior angle here. And another pairing be here. So notice those, if you trace those angles, they're not hooked together even. So it's two separate angles, two separate V's, I guess. All right, and the last pair is called same side interior angles. Same side of the transversal. But on and between the two lines, because it says interior, between the two lines on the same side of the transversal. Between the two lines. So I'm going to put a 1 here, and then the one that goes with it is on the same side of the transversal. So down below here on the same side of the transversal would be angle 2. And then another pair. If I put the 1 on the right side of the transversal, then the 2 is on the right side of the transversal also. Interior because it's between the two lines. All right, so we're going to practice naming those. We'll change our diagram and scramble up the numbers, see if you can pick out which ones they are. Got your pictures to go with those? Okay. So I'm going to put just a 1 and a 2, and why don't you grab your marker board. I want you to tell me what type I marked. All right, here are the 4. And there could be some other things like maybe I'm gonna try and trick you and put vertical angles or a linear pair of angles. So maybe could do some others. All right, so here's a number 1 and here's a number 2. Which type are they, or are they some other one that I'm trying to have you see? Write down which type they are, and then I think we'll have everyone show the same thing. All right, show me. Should be alternate exterior. Alternate exterior because here's the space that is between the two lines. 1 and 2 are not in between. They're on the outside of the two lines. Okay, next one. Let's put a 1 here and a 2 there. What type are they, if anything? Show me. Which one? The second one, alternate interior angles. Yes, that was correct. I think everybody that I saw got that one right. Okay, a 1 and a 2. Show me. This one should be corresponding. Corresponding, because this is the above the line and to the left of the transversal, above the line and to the left. Notice on corresponding, the one is an exterior angle and the other one's an interior angle. You're going to have one of each when it's corresponding. Okay, angle 1, angle 2. Show me. Okay, good. That is other. It's vertical angles. Vertical angles. I didn't give you any at the other intersection. Okay, how about a 1 and a 2? Did I do that one yet? Nope. There's a 1 and a 2. Show me. All right, same side, interior angles. All right, it appears that you're getting that. Now, if we turn the diagram, are you tired of 1 and 2?
Let's look at 7.
7, okay. Here's a 7 and here's a 4. What pair are they? You need to turn your head. Draw it and then turn the marker.
Gary, you're not supposed to show me.
Show me. Alternate interior angles. They're between the pair of lines, so it's interior. All right. 7 and 4. quite a few other, which is right. They are a linear pair. Why they're not same side interior? This is the transversal. They're not on the same side of the transversal. They're not alternate interiors because they're both at the same intersection. So that should have been other linear pair. How about 7 and 4? Show me. Okay, looks good. Alternate exterior angles. All right, so it doesn't seem like if I turn it that causes too much problem. Oh, let's go on. Now we got which one's the transversal depends upon where I put the angles. So there's part of the picture that you'll kind of block out. So if I put the 1 and the 2 here, I don't even need this part of the picture. Okay, so ignore this part, even if it's on my back. Ignore this part to come up with what they are. So if you're working this in your book, you can actually cover it up. Doesn't work too good when I try and cover it up. It still shows. All right, show me on this one. Good, same side interior angles, right? All right, let's do a 1 and a 2. Look at which part of the picture you can get rid of. You know what, I can do a screen shade. I can get rid of part of the picture. Show me. Boy, we got all kinds of answers on this one. I think there's about everything out there. I don't see vertical angles, but this one was other. And it's not even a linear pair. It's not even a vertical angles. Because with your transversal, one was exterior, one was interior, but they're not in the matching. That would have been corresponding. Oh, I forget what else I saw. Exteriors, this would be a corresponding situation. All right, let's try another one. How about angles 7 and 8? Show me. That was alternate interior. Get it? Okay, how about a 6 and a 5? Get rid of part of the picture. Show me. Alternate exterior angles. This is the space that's between them. So they're exterior on different sides of the transversal. It is a little bit harder when there's multiple lines there. And let's try, let's see which one we're going to go for a while. Let's go with a 5 and a 7. This one should be corresponding. You can get rid of the top part, and they're on the same side of the transversal, but this one's an exterior angle, and this is an interior angle, so they're in corresponding spots. So that's a little bit harder. You'll have to cover up part of your picture. Right, I want to try GeoGebra today with a little experiment, because these angles have a certain relationship when the lines are parallel. So I'm going to have you go to GeoGebra and open up a program that was already set up by somebody. Okay, so go to your GeoGebra app. I don't think I put these directions on my screen. Okay, under GeoGebra, it's a combination of geometry and algebra. Bring it up so I can give you the directions in the right order. Okay, I want you to go to a created material already. Catch up with you here. Okay, search GeoGebra materials. And you're supposed to go to one that was called, what is it called? Parallels. Try parallels. Parallel lines. Should have written it down. So parallel lines conjectures. And the person is Fred Schmitz. Find that one? Okay, go to that one. Can't do this. I wanted you to do that if you wanted to get access. All right, so view that one or edit it. Maybe that's why some were having trouble last time. Are you picking view or edit?
I think you
Is it really big?
Oh, if you choose edit, it's really big.
Okay. If you chose view, then it's small. Okay. It's got all these words on top of it. Okay, I would like to get rid of those. So what I did was touched it, and then see the double arrow icon. It's kind of off to this side as like an XY axis is what it looks like. If you pick that, then there is a choice of show hide label. And if I click that, then it's saying select objects.
I'm confused.
Okay, maybe I can't do that when I'm in the.
Okay, I selected it and it just kind of wound it to the other part of it. I don't know that one.
Yeah, we haven't used this before, so we're experimenting a little bit. Okay, now I did this before,
Okay, you just have to hit delete. Where's delete?
just on that screen instead of
Yeah,
hide.
it's on the.
Okay. Okay, some key things, this is the one that we're going to, way over here, if you can't select something, see that arrow, that pointer? You probably have to hit that in order to select the pointer. Touch on that text. Mine's not working now. Okay, when I go to this one, I can change it to trash. All right. And then you can touch it and it'll disappear.
It is at the bottom, see, it says delete. That is the bottom.
Okay, and if you're having trouble, just select that set of directions and just pull it out of the screen. Okay, now go back to the pointer. I want you to see how this can move. Okay, what this person has done is set it up so that it can be used in a variety of ways, but they set it up with parallel lines. So if you do the pointer and choose point B, you can slide point B around, and as you turn point B, can you tell that there's two parallel lines set up in this? That it's always, we're always getting parallel lines, okay? All right, so what we're gonna do is measure some of the angles, like the corresponding angles or the alternate interior angles, things like that. Okay, right now my picture looks about like this.
What if your picture looks like this?
Okay, choose your point B if you can and stretch it back out.
I'm just on the midpoint.
Well, you have to pick a point to move. Okay, and not every point can be selected. I see point A, B, and C are real dark, and the others are lighter. I'm thinking the ones in dark are maybe the ones that we can move. The light ones move in relation to those others. Point D is moving. Okay. All right. So forget what I just said. You can move a lot of things on there. Okay.
Oh, and you can change the color.
That you probably can. Okay. Another icon I want you to look at is this one that looks like an angle, and it has like an A in there. Actually, it's a theta. Or beta. So pick that one. That one is going to have us choose measuring an angle. And the first one on it is the one that I want you to choose. It just says angle. So select that one. Now at the bottom it says select 3 points or 2 lines. We're going to select 3 points. Now what's weird is you have to do them in an order that would go clock or counterclockwise. So I'm going to select point B, then point A, and then over here is my point H. If I go in the order B, A, H, it will measure this angle. Okay, pick angle. Okay, now touch point B, A, then H. Did you get a degree measurement to pop up?
Yeah.
Now, if you can't read it well, go to the pointer and get the move. Then you can select that actual measurement and you can slide it out a bit so that you can read it. Yours is probably a different number than what mine is. Okay? Does anyone need a stylus because your finger's not working very well? No? Okay. Now I want you to measure the angle that would be corresponding to this one. So what would be the points? D, C, and then you could use A or H for that side. So I want you to measure this angle that would be its corresponding angle. You have to maybe go back to the angle selection so that it will measure that same one. If you don't have a C, it could be that it's pushed way out or all scrambled up, maybe it out of the way. All right, are we working this okay? Raise your hand if you're not. Okay, how many of you are with me? Okay, do we need some help? McKenna, do we need some help getting to something? No? Okay, what does it look like the relationship is with your corresponding angles? They were the same when you did that? Okay, what I want to do is have you see, do they stay the same? So let's move some things around. So go back to your move And I think point B is a good one that you can slide or twist with. So get point B to move, making your parallels move. And as you move your parallels, are your angles staying the same?
What? No, we are 60 degrees. I don't want any. What?
Oh, make it
Hold it.
Okay, those of you that are getting it to work, did they stay congruent as you moved it around? Yes. Okay, so we're getting the corresponding angles to work for us, and we're getting them to be congruent. Okay, let's try another pair. Okay, on this one, if we measure, let's see, let's do alternate exterior. Actually, let's go in order. I think your next one will be interior. Alternate and interior angles. Okay, are either of these angles interior? Yes, this one is, right? Okay, so alternate interior to this one would be the angle over here. Okay, we have to click it in a counterclockwise order. So is there a point out here? G? Okay, so you need to measure the angle. And we want to click G, A, C. So that you're measuring that angle. G, A, C. And how does it compare to the others? Is the same? And then move it around a bit. Puts it as Y. We must have something selected. Okay, alternate interior angles. Was it congruent or was it something else? Did anyone get that to measure? Raise your hand if you got angle GAC to measure for you. Okay, got quite a few. All right, that one should be equal because look at your numbers. If this were 70-degree angle, wouldn't the vertical angle be 70? So those should be equal, and this one should be the same. And what other one would be equal?
C.
This one, right. So one more to try, FCE. Can you get FCE to measure?
Yeah.
to move, are you selecting the move?
Yeah, but it's all messed up.
Well, I'm not done.
Yeah, this would be something that would be fun for you to experiment with. You have some fifth period or snow day or something like that.
So tomorrow?
Maybe. Okay, one more I want you to do. There's one pair we didn't check out. Same side interior angles. Now, depending upon which ones we want to look at, write this in here. I don't have any same side interior angles measured yet. Let's have you measure one. Let's try and have you measure angle CAB. My picture's looking like a mess here. CAB. Can you get that one? I got my numbers backwards. It shouldn't be 70s. So what are you coming up with? Is that the same as all the other ones?
No.
No. How's it related?
It's all,
What do you mean the other measurement?
like, a 180 and 180, it's like, adds up to where they both.
Okay, so that same side interior angles, they're not congruent. They are, what's the word when we say they add up to 180? They add up to 180, two angles that add up to 180? Supplementary. So the same side interior angles are supplementary, not the same. All right, kind of an interesting program. Probably have to mess with it a little bit, and I haven't used it for a while, but getting familiar with what the different choices are and whether you have to select it first and then do the icon or the other order.
Are we gonna have a sentence today?
Okay, let's get our notes down. So put your GeoGebra to the side. Oh, not Siri. All right, let's write down those theorems and postulate based upon what my notes were up here. There's 4 different ones. The first one is a postulate, the others are theorems. Not a lot of difference as far as you're concerned, but one of them isn't proven, the others can be. And the first one, and we're going to use that same diagram and angles on every picture. So you might just put that off to the side so that you would know where angle 1, 2, 3, 4, 5, 6, 7, 8 are. The corresponding angle postulate says, if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. When we were on the iPad, they were parallel lines all the time. So with that picture, I want to fill out the if and the then part. If we know what, then we come up with what. So like putting it from the words into the diagram. And these are in section 3, 4. Are we ready for the fill in the blanks? Okay, Allie, what do you think? If what, then what?
If we know 2, then we know 6.
Now, if 2 parallel lines are cut by a transversal. So for the if part, you have to tell me what 2 lines are parallel.
If P and Q are parallel,
That's the right symbol.
yes.
If P is parallel to Q, then
The R is a transversal.
correct it is. I'm actually not going to write that down, but, well, I guess I could. Okay, R is the transversal. Then give me corresponding angles that are congruent. Angle 2, and what do we want to say about it?
Is congruent
Is congruent
to angle 6.
to angle 6. So if the lines are parallel, angle 2 and angle 6 will be congruent. Yes.
So why did you not want to write R's using transversal?
I guess I just hadn't before, but we might as well because it does mention the transversal. So I just had never really thought about putting that down before. Okay, got that one? Okay, there are going to be a total of 4 that are kind of like this. The next one is a theorem, alternate interior angle theorem. If 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. So if 2 parallel lines, so our if part down here again is going to be P parallel to Q and R is the transversal. Then alternate interior angles are congruent. Which angles and how do we state it? Carrie?
If P is parallel to Q, then 4 is congruent to 6.
Angle 4 would be congruent to angle 6. 4, angle 6. Yep, those are alternate interior. As long as the lines are parallel. Next one's going to be alternate exterior angles. So what's the theorem number going to be?
3.6.
3.6, alternate exterior angle theorem. Same thing, but alternate exterior angle instead. So if you're ready to think about the next one, you can fill it in. Some of you write faster than others. And this is lesson 3.4 if you're not keeping up with my notes. Okay, next screen. Alternate exterior angles theorem. Maybe by now you can abbreviate a few of the words since you know what it's saying. If 2 parallel lines are cut by a transversal, then alternate exterior angles are congruent. Okay, so if P is parallel to Q, and R is the transversal, then we need to pick out alternate exterior angles. Say that they're congruent. I know you two have it. Alternate exterior angles. Jaden, can you tell me which angles would be alternate exterior? One and 7 would be a pair. The other pair he could have said 2 and 8. So then angle 1 is congruent to angle 7. 1, angle 7. So far, we would be setting them equal to each other, like if we're solving a problem. But what's the last pair's relationship going to be? Same side interior angles, we got to be supplements. What supplementary mean? They add up to 180. Kind of filling some time, so looks like we're done on that one. Okay, the last one then, same side interior angles theorem. again, you can abbreviate some of your common words. If two parallel lines are cut by a transversal, so my if part's still P parallel to Q, R is the transversal. Then, what are we going to say on this one? Then how do we say they're supplementary? We said that means they add up. Morgan? Okay, measure of angle 4 plus measure of angle 5 equals 180 degrees. Okay, correct. We could do it that way. So in this section, you're going to be finding angle measures. Some of the diagrams, you're just going to find the actual numbers, like what we did here. Otherwise, there are some where you're going to have to write an equation. So let's take a quick look at some examples. Everybody ready? Okay, so this type, what are the measured angles? I'll point to an angle and you tell me how much it is. 120 because that's corresponding angles. Okay?
120.
120 because they are alternate interior. Okay? This one.
60.
That one's 60. These angles would be same side interior. Okay? And I probably could go this one. 120. Either vertical or alternate exterior. This one?
60. 60.
And how do we get those so quickly? Probably a lot of linear pairs where they're just supplements. Okay, I think we got that idea. Let's have you find this angle. How many degrees is angle 2? 70. Why, Ben? Okay, now these two angles are not vertical, or do you mean this one?
Yep.
Okay, that one's 70. And then how do you get from there to angle 2? Help him out? Well, they are on the same side of the transversal, but they're not both interior corresponding. Right. So he could do that. He could have just gone from the original 70 to get this one by, where are they? Alternate interior, correct. Let's have you find this one. How many degrees? Okay. If you have a reason. Is it on? Okay, very good. Alternate exterior angles, 87 degrees. Right, how about this angle? Okay.
110.
Okay, are you doing supplements? I think you're subtracting wrong. Subtract from 180?
90, sorry.
Yep, so it should be 90. Same side interior angles. How about when there's some variables involved? Jaden, are you seeing this? How would you figure out x on this one? I know I'm going a little bit longer because we spent some time on the iPad. How would you figure out this one? Sydney?
Find out what x is.
How would we find what x is?
You'd subtract 10
From what?
from 90.
So what equation do you want me to write? Sounds like she was indicating I would do that. Why would I set them equal?
So you could do like
What kind are they?
Alternate.
They are alternate interiors. And so, since the lines are parallel, they had to be the same. Okay, so you're right, subtract 10 and divide by 2. So x was 40. All right, and this one as our last example. Lines are parallel. Are they one of our 4 pairings? Yep, which type? Okay, so we need to set them up to be supplements. What's that mean, Cody? Supplements. Okay, so they add up to 180. So 78 plus x minus 2 has to be 180 degrees total. Simplifying that, 78 minus 2, 76. And then subtract 76, 104. Because if this is 104, the angle would be 102 total. And if that angle's 102 and this one's 78, that makes the supplements. Okay. Of the first page that I give you on the assignment is just identifying, are they corresponding, or are they alternate interior, that type. The second page is where you're figuring out the degree measurement. So here's what we'll work on today, tomorrow, however many days before we meet again. So that is just like identifying which ones they are, and then figuring the angle measures. We do have a quiz the next time we're together, and it's on 3.1 to 3.2. I would suggest you do page 120, number 1 through 7. I will put that as an optional. It should help you do better on the quiz. So that would be your focus. Would it result in extra points? Most likely. Just kidding. Okay. And figure out some things on GeoGebra.
That's great.
Mhm.
So if we're not here at school tomorrow, that means I'm not going to see you till Monday. So what about the worksheet?
What about the worksheet?
Do I
Well,
just do it on Monday then?
I guess you could check